So now let's take a look at digraphs. And digraphs are just an abbreviation for the word directed graphs. We've already talked about regular graphs, so now we are going to look at situations where all of our edges have direction. And the direction is going to be represented by arrows. So think of it as like all of the edges are one-way streets. So you can only go this direction on the edge AB. You cannot go the other direction from B to A. So we do have some different vocabulary for digraphs. The first is that instead of calling an edge, we are going to call it an arc. So an arc is just the edge of a digraph. And we do want to make sure that we write the letters for the edge in a specific order. For a regular graph, we could write AB or BA to represent the edge. With the arcs, this arc from A to B, we have to write as AB, not BA, because the edge starts at A and then goes to B. We can also talk about the starting vertex and the ending vertex of an arc. So again, looking at arc AB, the starting vertex is going to be vertex A, where the tail of the arrow is. So in this situation, vertex A is our starting vertex. The ending vertex is where the point of the arrow is. So in this particular situation, B would be our ending vertex. The next thing we can talk about here is the arc set. So similar to how we talked about the vertex set and the edge set in a regular graph, we could talk about the vertex set and an arc set of a digraph. So our arc set, and you do need to make sure that you write all of the arcs from the starting vertex to the ending vertex. So we have A, B, and I like to write them all in alphabetical order. So all of the edges that start at A are A, B, and AC. Edges that start at B, or arcs that start at B, my bad, are B, D. Arcs that start at C, CA, CD, CE. Arcs that start at D, there are none. Arcs that start at E, we have EA and ED. And that should be it. I have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So I'm good there. Next, the next few vocabulary words are specific to a digraph, and they're a little bit weird. So we can say that when looking at arc AB, A is incident to B. So this means that from A, we can go to B. Similarly, if we look at, again, the arc AB, we can say B is incident from A, meaning we can get to B from A. Next, we can talk about adjacent arcs, and adjacent has a very specific meaning here. We can say that BD is adjacent to AB because BD's starting vertex is the same as AB's ending vertex. Okay. We could not switch them around and say that AB is adjacent to BD because AB does not start where BD ends. Next, we have a path. And a path is very similar to what we talked about with regular graphs, except that you can only travel one direction along the arc. The specific definition of a path is that each arc is adjacent to the previous arc, and we cannot repeat arcs. Okay? So each arc is going to start where the previous arc ended, and we're not going to repeat arcs. Because if we repeat arcs, then at some point we have created a cycle. And a cycle is like a circuit. Okay, you are starting and ending at the same vertex and moving the correct direction along each arc. So A, C, E, A would be a cycle. The last thing to look at here is in degree and out degree. On a regular graph, we talked about the degree of each vertex, but because we have starting vertices and ending vertices, we need to be a little more specific here. So the out degree is going to be the number of arcs with a vertex as its starting vertex. So I'm going to look here specifically at vertex C. So looking at vertex C, how many arcs are leaving C? There are 3. We have CA, CE, and CD. So we're going to use the notation degree with a little plus as your exponent of C equals 3. Similarly, we can talk about the in degree of a vertex, which would be the number of arcs with, again, I'm going to look at vertex C, C as its ending vertex. So how many arcs are coming in to vertex C? There's 1, and we can write it as degree minus of C is equal to 1. So that's all of our vocabulary about digraphs. Now we want to take scheduling and digraphs and put them together. So if we look at this situation here, let's pretend it's the year 2050 and we're starting to build colonies on Mars. All humans live in Martian habitation units, or MHUs, that are assembled by habitat unit building robots. Assembly of an MHU consists of 15 separate tasks, and there are 17 different precedence relations among the tasks. So here we have a chart that lists out all of our tasks that have to happen to build these MHUs. We have an abbreviation for each of them, and then an estimate of the processing time. And then we have our precedence relations. When we draw our digraph, all of the tasks are going to be vertices, and all of our precedence relations are going to represent arcs. So, when you start drawing a project digraph, you are always going to start with an extra vertex that we just label as start. And that has a processing time of 0. Then we want to look and see what tasks can be started right now. So what tasks have no tasks that have to come before them? And that's going to be our first 4 tasks here. Assemble pad, assemble flooring, assemble wall units, and assemble the dome frame. So I'm going to start them here. Assemble pad, assemble flooring, assemble wall units, and assemble dome frame. Then from my start vertex, I'm going to draw an arc to each of these tasks. So now that I'm done with those first 4 tasks, I'm going to go ahead and cross those off my to-do list. And then I'm going to look at the next task, install floors. If I look at the precedence relation, install floors has to come after assembling the pad and assembling the flooring. So I'm going to put it here. Install floors, assemble the pad has to happen, and assemble the floor has to happen. If I look at the next one, install interior walls, that has to come after I assemble the wall units and after I install the floors. So I'm going to put that here. Install walls after this one and after this one. Okay, and then you continue doing this for all of the tasks, drawing an arc for each precedence relation. So go ahead and pause the video here, try to finish up the rest of this project digraph, and then come back and click play to check your answer. So hopefully your project digraph looks something like this. The shapes don't have to be exactly the same as the shapes that I used, but you do want to make sure that the last tasks all come together to an ending task. Again, so we have a starting task with processing time 0. We also have an ending task with a processing time 0. In general, you want your project digraph to flow from left to right because that's how we read. Other than that, the rest of it can be a slightly different shape, and that's fine. So next class, we will talk about how to use this project digraph to create a schedule.